Good morning, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator at EandM. Thank you for attending our Learn in 30 webinar titled Easy Solutions to Complex Motor Management Problems with Connectivity to the Cloud. After the webinar, we'll be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or you can email us at webinar@eandm.com. I'd like to introduce your presenter for this morning, Mark Berger with Siemens Industry, to get us started. Good morning, Mark.
Good morning, everyone. All right, I sure appreciate your time for joining us today on this 30 minutes. I'm going to start off with just a quick introduction. My name is Applications Resource Consultant for the Electrical Products Group of Siemens Smart Infrastructure. I've been with Siemens for about 15 years. Was a salesman, a general purpose sales guy for all of Utah, Western Wyoming, and Eastern Nevada for 10 years with Siemens. And I've been in this position for about 3 years. I truly appreciate taking the time out of your busy schedules and joining me today. And before I proceed, just want to give a quick overview of our job. My job is to help customers with safety relays, controls products that communicate to PLCs, such as an IO-Link, Profinet. Simha Code is another one, and then anything to do with soft starters, and then general proof of concepts we can help with on that. So let's move on to our topic today with Simha Code. Where does the name come from? Well, Siemens likes acronyms, and so we like putting SI in front of everything. Simation, Simotion, and in this case is the same. So Siemens Motor Control Device. This is your overload. This is what you put into your motor control center or into a motor control panel, and this would take the place of your overload. Just to give a brief overview, what it can do for you is that it can monitor. You can listen to your motor. We can monitor temperatures. We can monitor anything that has to do with the process that motor is turning, such as vibration. Again, I stated temperatures. And then it controls. This is where you learn local wiring of the stop-start stations for it. Maybe you have a 2-wire or 3-wire. And then, of course, it is your overload protection. So it is a true motor management system. This is if you came to Siemens and asked us to give you a smart MCC, this is what we would put into each individual bucket would be a Simha Code. So there are many ways of forms of control. We'll talk about that off the bat. There's a 2-wire jog, local remote, local forward reverse, run permissives. I have a remote HOA, and so forth. These are the different types of control that Simha Code can handle. Here's just a standard HOA circuit that you may see in the PLC. You have your standard handoff auto, start, stop. And then you have these contacts here, your motor, verify, and it is your interlock or your sealing circuit to keep the motor running once you push start. And here's some of the logic that you see. Here's that sealing circuit over here. The right motor management system can change the equation of all this. So for an example, here's a hardwired motor starter logic. And we're going to wire this up all hardwired. We're putting it into input cards and so forth. We're wiring up the HOA. Notice here are some auxiliary contacts that's going to be required. And then if you're wanting to measure the current that's going on with that motor, you're going to have an analog in. So this kind of gives you a bill of materials of roughly about this much, understanding that the feet of wire, just depending on how far away your inputs and outputs to the PLC is, and then where you have to hardwire it. But you have to have 3 digital ins, 1 digital out, 1 analog in, some extra starter contacts, current transformer, and current transducer, and then of course some twisted pair wire to bring that in. What type of things you get with this? You could lose the output to turn on the motor. You know if the contactor is closed, but is the motor actually running? meaning that unless you have a visual indication, you don't know if the motor's running. So that's where the current is coming into play. But then in addition, if the motor's running, but maybe the coupler is broke that ties to the load that the motor is supposed to be turning, you've lost that. Also, the auto position may not be working, and then overload trip and so forth. And then the data for the amperage of the motor for it may be a little bit pricey for you. But here's just an example of a hardwired system for about 30 motors here on the left-hand side, and then another project that had a few motors to it too. And this is where all these wires are being wired into a motor control center bucket. Okay, we introduce the Simha Code, and note that it removes the extra contactor that is needed for the sealing circuit. And note that it removes also the contactor for the overload. Because the Simha Code is the overload, we are removing those. And then in addition, we're removing the CT. We don't need that because the Simha Code has a CT, a current transducer, and a voltage transducer if you want to measure voltage, all in one unit. Notice also the wiring comes local to the Simha Code. The Simha Code comes with a 24-volt power supply that can excitate your stop station at the MCC door, and also excitate the HOA also in the MCC door. So what this does now is it reduces a significant amount of wiring. Now that you're not wiring all those hard wires into place, and then the communication back to the PLC is via a field bus, which could be Profinet, Ethernet IP, Modbus RTU, or Profibus. Today we're going to center on Profinet. Your stop-start. Again, here's the field bus outputs. And again, to emphasize, those two contactors go away with Simha Code being introduced. So now let's talk about monitoring. What's the difference between measuring and monitoring? Local measuring only provides raw data values in the remote, meaning the current or the voltage. But monitoring also provides an analysis of those raw values of measuring. So for instance, if we were monitoring, we could monitor and detect it with the CTs, but then how will we respond to those things, detect the event? So maybe a limit switch or voltage or current maybe has gone too high, or voltages sags or swells, or loss of phase, overload case, pressure switch. And then we can also monitor is energy, kilowatt per hour, or we can monitor that a motor is stalled. And then again, I've emphasized is that we can monitor temperature, and we can also monitor levels, because we can have an analog input into the Simha Code of 4 to 20 milliamp. These are all different types of monitoring that the Simha Code can provide. Best response to these monitoring is, do we trip? Do we stop the motor because we do have a problem, an external fault or an internal fault? Or do we warn the operators, let them know that there is maybe a problem as we're monitoring? Or do we just signal and let them know that, hey, here's the situation, what would you like to do with it? And you're given a very flexible way to go about how you act and react to any of these monitoring cases that you have. Okay, just a brief overview of the motor management system. Here's a list of some of the things that it can do. Solid state overload. It is your overload. It can monitor your relay current being drawn by the motor. Also your voltage coming in. Power factor. Phase monitoring relay. Also is a jam protection relay if you'd like. You know, I've been in the electrical business for a few years. Back in the day, there was a Westinghouse reversing starter, and they had an add-on to it called a jam module. And this is an experience that I've had out in Wyoming at a facility out there that had some hammer mills. And what they were doing was crushing some material, and every once in a while, this material would jam up the hammer mill. And instead of tripping the motor, they just wanted it to reverse. And so what they used was a jam protection. And this is an old Westinghouse contactor. And then what he would do is just that he would see the current go to a certain level. It would stop going in the direction of clockwise. And then it would reverse it and go counterclockwise because it didn't matter which direction that it was going to move. Well, they found out that they couldn't get any more of these jam modules anymore from the manufacturer, and they couldn't find them on eBay. So they came to me and asked me about this, and so I was able to show them in SIMOCODE that there was a means of doing a jam protection and be able to click and do the logic for it. And then in addition, across the way, I was able to count how many times that jam protection was energized and reversed. And if it continued to jam after 2 or 3 times in a time period, then that's when they called in the operator and let them know that they needed to look at this hammer mill to figure out what's going on. Temperature monitoring relay. Let's move on to that. It's key that we have to take some of this data and use it not just to monitor the motor, but monitor the process that the motor's turning. Case in point, you have a gearbox and nobody's looked at it for a while. Maybe the PM hasn't been done for a while and the oil in it has leaked a little bit or something that occasion. And with the turning of that gearbox, it's overheating. And that heat is not good for motors, nor is it good for gearboxes. Put an RTD on the gearbox and have an external fault that could trip the process that you're using, and let the operators know that it's not the motor that is bad. Overload is fine, but the process that you're turning has a problem, such as a gearbox, or maybe a head pulley on a conveyor belt, or something otherwise that you're on a pillow block bearing or something to the case. Also, we have ground fault relay that you could use. And then there's some additional digital ins, and there is some analog ins. The SIMOCODE can stand alone by itself. It does not require a PLC. It is a standalone system. To bring it into a big distributed control system is no problem. It can report back to a controller. But if you had a simple pump panel and you wanted to monitor the pressure going out. So I live in Ogden, Utah, and I'm about an hour south of the Idaho border. And let's say that I have a friend of mine that that grows potatoes, and he's using his pivot to water his potatoes. And maybe a pipe breaks or some type of coupler breaks and water sprays everywhere, and it floods his fields and maybe even floods his neighbor's farms. Well, we could put an analog pressure transducer out on that pivot on the far point, set some process windows of the pressure in that system, and we could have the SIMOCODE trip if it sees that the pressure drops out of the nominal pressure of the processes of the pivot, and trip for them so that nothing else happens, and then give a signal to let them know that maybe there's a problem with the pumping, but nothing wrong with the motor because it's not an overload state. It's still pumping water, but we may have had a pressure drop or something had changed in the process of pumping water. Just an idea for that application of using an analog. You could also use it for maybe a vibration sensor. We do have safety with SIMOCODE. We can go up to SEAL 3. We do power monitoring, energy metering. We could have counters of maybe how many times the motor's turned on and off, how many times that it hasn't been on, how long the motor's been energized versus how long the bucket's been energized, for some maybe key performance indicators. We have timers, signal conditioners, which we would use in conjunction with the 4 to 20 milliamp input, and then network interfaces. Again, the SIMOCODE talks Profinet, Profibus, Ethernet IP, and Modbus RTU. The last item that you probably have came to here for, as we talked about, is talking about the cloud and maybe an edge device to where you're accumulating data. How does the SIMOCODE talk to that device or pass all these motor management functionalities and information up to a cloud device? Well, the SIMOCODE comes built in the Profinet version with OPCUA. And I'm going to demonstrate that real quick. So I'm going to switch over to the programming software for the SIMOCODE, which is TIA Portal. Here's TIA Portal. And I have configured in the portal. This is the software that configures all of our PLCs with Siemens, configures our SIMOCODEs, configures our communications and so forth with it. And within here, the SIMOCODE, I've got a current transducer, also voltage monitoring. I've got the basic unit of SIMOCODE. I've got a digital input addition module, which could be an analog or it could be the RTD to measure the temperature that I talked about. And then also I have an operator panel with it. The SIMOCODE comes standard with Profinet, an OPCUA server. I've activated it, I've checked the box, and in addition, it comes with a web server to where that you have a web page to where that you could look at that web page and get the statuses of it without even pulling up any software. This is a great tool so that if you're out in the field, you don't maybe have the software, the TI portal on a laptop, you can just plug into the SIMCODE and that you can type in the IP address and look at the web server for it. What I'm going to focus on is the OPCUA server today. Please note that I'm giving quite a quick overview of the SIMCODE. There's so much I could show, but for today, we're going to look at the OPCUA. So I've turned it on, I've downloaded it, and I just want to show you a couple things. So here's the software, is that I can go in and do some machine monitoring in the software and turning on. So here's voltage, here's current limits, here's cosine phi, here's active power, operating hours, etc. All of this is laying deactivated, and it can be turned on by the person who is setting it up, the engineer or the operator that wants to get this information out. But what have I said? I'm going to go off and I'm going to pass some of this information via OPCUA to where you could take it into a cloud device or maybe some type of SCADA system. Or one of the most prevalent things that I see out there is historians. There's many historians out there to where they're really storing all the activated tags or set points or values that are coming across. So for today, to show the OPCUA server, I have a software called OPCUA Expert. And this is a free download. It's offered out on the internet by a company called Unified Automation. And this is an OPCUA client. OPCUA is a client server application. My SIMOCODE is the server, and this software is the client. So I'm going to go out and find a new server, add it. And I know the IP address, opc.tcp of my SIMOCODE, and it's 192.168.0.20. I'm going to click there and tell it to go look for it. And it found my OPCUA server right here. Now I'm going to double click there. And for my case today, I'm not going to do any security because I have a closed system with my network. So I'm going to hit none. And then once it puts it into my servers that I can see, I'm going to right click and say, please connect to it. Once I do that, it comes up with the certificate validation. I'm going to say accept, continue. And then once that happens, it puts in down here below the addresses of the servers that I could reach out to. And here's my SIMOCODE Profinet Pro V. Double click here, and here is all the tags. All these tags are automatically generated. There's nothing that you need to do to generate these tags that I'm about to show you. They are quickly done for you, and all you have to do is know. So I'm going to go over here to measured values. And let's say that I want to look at current on L1, L2, and L3, and I'm dragging these out. Now with the cloud, there would be some type of tag server that you would make this connection with. And that's what I'm simulating here with the UA tool, is that cloud server where you would make the connections to the OPCUA server, or pardon me, the OPCUA connections with my SIMOCODE, the server, and then you're making the client connections. The other thing that I would like to do is look at my voltage for L1, L2, and L3. And note that my pump is already, or my SIMOCODE is receiving the voltages, but current's not flowing because I don't have it running at the moment. And I'm going to turn that and turn it on right now. Okay, current is running. Please note the two differences. I have a difference of this one here is the percentage of the full load amps of the motor, and then up here is the actual current draw. So my demo has 0.5 amps, half an amp for its full load amps. So I can have it in percentage or I can show it in raw value. These connections here then can be pulled up into your cloud. This is a great way of historian of showing how the process is working. Maybe process creep could be shown here too over time. Your historian or your cloud will be monitoring this at an interval of what you set at of maybe a sample per second or a sample for every 1 minute. If it's a big thermo or if it's a big system that you really don't need to take a sample every second, maybe just every minute would be sufficient that you can do. But now let's talk a little bit about some of the external things. Again, my SIMOCODE is your overload and it is your current transducer and voltage transducer. But if I wanted to go off and maybe have an external fault that may transpire with it, I would like to create that. So now I'm going to go back to my software. Here I am again within the SIMOCODE software, and I'm going to go to maybe some standard functions, and I'm going to go to the external fault. Within the external fault, I'm going to go to external fault number 1. Now if I go here, notice that I've made a marking of down here on this external fault, and this could be my vibration sensor, this could be my temperature as I've put here, and I've put in this marking. I have a temperature that I've typed in as motor temp 90, meaning that it's at 90 degrees of the motor, and it is one of my RTDs in my motor. That's at the 90 degrees of the motor as you look at it clockwise. So that is set up. I've downloaded to the SIMOCODE. I go to OPCUA, and I go to my diagnostics, and I go to events, I believe. Bear with me for a second. I scroll down. Notice here's external fault 2, 3, 4, and 5. If I switch back to the software, notice here's external 2, 3, 4, 5. But external fault number 1 is not showing up. Switch back to the tool, and if I slowly go down, it's in an alphabetical order. I can notice that right here, this event called motor temp 90. So I can go in and change the OPCUA tags by going to the software and coming in here and putting in marking. If it's blank, then it defaults back to external fault 1. This is a very powerful tool to help your data in your cloud so that you know that if you do have an external fault, such as a temperature or maybe a vibration, or with the case of my Idaho farmer and his pump spraying pressure everywhere, spraying water everywhere, and his pressure drops significantly, instead of him getting external fault and he has no idea what that means, I can name that external fault to whatever he wanted. And in his case, I just said pressure drop, and he was able to see that that happens. To extend this a little further, I told you of the web page that SIMOCODE has. When you do this in the web page, it automatically does the same thing. Come to the web page, and the IP address takes you into the SIMOCODE web page. Hit enter. Here's my motor running, device is okay. And I can go down here to my maintenance and statistical data, or my faults warnings, sorry. Click on that. And there you go. My external fault has here listed motor temp 90. I can change all these to whatever I want to name those as for that. This is extremely powerful, I believe, and it helps that we are not just looking at the motor itself of how many times it turns on and off, which it does, but then also what we're doing is extending ourselves with this motor management system to look at the entire process that the motor's turning, gearboxes, pumps, etc., etc. And we're able to bring in data to help diagnose it quickly, get the response that is needed from maintenance or operators, and then also down the road, look at the time and what is going on process creep or where maybe PMs need to be taken care of. Because we can also, in the software, can set up a PM. A lot of PMs on motors and so forth could be done with calendar dates. But in my case, with the Simha Code, I could come in here and I could go up here and put in 600 hours on the motor of running accumulatively. And then I could turn in and say that I want to signal to the operator to let them know that that motor is accumulatively run for 600 hours and it's time to do a preventive maintenance. He schedules it down, goes out, checks the motor box, the wiring junction box. He checks the alignment, grease the zerts, etc., and he's off to the races. So all this power is very, very transparent when it comes to with the OPCUA client and then the web page itself. I truly appreciate your time. Just to recap what I've gone through, please understand that it's just a quick overview within 30 minutes. There's so much more that I would love to show. Please feel free to reach out to the EandM crew and any of your Siemens crew that you know of, and we'd be glad to give a little more of a detailed overview of it. I truly appreciate your time. Just to recap again, the Simha Code is your monitoring, listening to the motor, it's protecting the motor, and then it's controlling the motor. And what this helps you down the road is that we're reducing code in your PLC because most of the code is in the Simha Code for you. What your controller becomes in a distributed control system is kind of a traffic cop monitoring alarms and set points so that it keeps the process running properly. But the Simha Code is a partner in managing your motor, monitoring, and protecting the entire process that motor is turning. I appreciate the opportunity again, and I apologize. This is awfully quick and there's a lot to show. Please, again, call us. We'd love to go a little deeper in and look at your specific applications for that. And with that said, Deidre, I will turn it over to you. And thank you again.
Thank you, Mark. So right now we'll open it up for a couple of questions. Please type any questions you have into the chat box or Q&A box, or you can email us at webinar@eandm.com. I'm checking the chat box and Q&A box right now. It doesn't look like we have any questions, Mark. So thank you, Mark, and everyone who attended today. If you would like to review any portion of this webinar, a recording will be available on our YouTube channel and on our website at EandM.com. We hope to have you again next Friday for our Learn in 30 on sizing a general purpose drive. You can register for that webinar on our website at EandM.com. Thank you so much, everyone.